Hello, we are going to go over the November 2022 um, external assessment for standard level applications and interpretation, paper one. I'm going to go through this as quickly as I can, skipping calculator or calculations and letting you pause to do your own calculations as you go so that you can follow along. But I want to make sure I don't take too much of your time and that you can work at your own pace. So we'll start with number one. We see that Kachina is standing at point K, and we've got all this information here, but we are asked in part A to find the angle of elevation from the ship to Kachina. So that's key here. Well, there are two key things. Angle of elevation always means the angle made with the horizontal. And so we're looking at the angle made from the ship. So we're starting at the ship right here, looking at Kachina at K, and we're looking for the angle made with the horizontal, which is the water line right here. So there's theta. This creates a right triangle. And so we should think to use a trig identity that we have the opposite side to theta and the hypotenuse. And so that tells us to use sine. So the sine of theta equals the opposite side 218 over the hypotenuse 1200. And when you evaluate the inverse sine of 218 over 1200, you get that theta equals 10.5 degrees. Make sure, of course, that your calculator is in degrees mode. For part B, we're looking for the horizontal distance from the base of the cliff to the ship. So this distance from the ship to the cliff, we'll call that x, and we can use Pythagorean theorem to do that. We would set it up as 218 squared plus x squared, because those are the legs, equals 1200 squared, which is the hypotenuse. And from that, we get that x would equal, after solving, and don't forget to take the square root, x equals 1180.03, there's more. Remember that for IB, we round to three significant figures unless told otherwise. So this would be 1180 meters. And that's our final answer. And for part C, write down your answer to part B in the form of A times 10 to the K, where A is between 1 and 10, and that just wants us to write it in scientific notation. So we look at the notation 1180, we identify that the decimal is at the end, and we move it over 3 places to get it to where it's a one digit number, or a value between 1 and 10. And so we have 1.18 times 10, since we moved it 3 places, times 10 to the third meters. And that's our answer. For this whole set of problems, this is all enough to write. You don't have to write a whole lot, but definitely write out things that you are doing so that your evaluator can see where you came up with this information. The things that I highlighted right here are important to write down, as well as your answer, of course, and it's always a good idea to box your answer. Moving on to number 2. We have a table here with some information about trees that were planted. In 1 month, there were 85 trees planted, and then every month after that were 30 trees per month. We are finding the number of trees to be planted in the 15th month. And this, you could just add 30, 12 more times and figure it out by hand. But we can use an arithmetic sequence, since there are 30 trees being added each month. I want to show you that the arithmetic sequence formula can be found in your formula booklet right here. Right here at the top, the nth term of an arithmetic sequence. We want the 15th term, so that's going to be U15. If you look right here, equals U1, or the first term, plus n minus 1 times d, and n is the term number and d is the common difference. I'm going to go ahead and point your attention to the sum of the n terms of the arithmetic sequence, which we'll use the second form of this equation, that the sum Sn equals n over 2 times u1 plus un, because that's going to come up in the next part of this problem. But back to part A, we want the 15th month, so that is u15 equals u1, or 85, plus 15, n minus 1, or 15 minus 1, times 30. And when you evaluate that, you're going to get 505 trees planted in the 15th month. Part B, though, wants the total number of trees. So this is where we're going to go back to that second equation you saw there in your formula booklet, Sn of 15, or the sum of the first 15 terms. Here we use n over 15, or n over 2, so 15 over 2, times the first term, which is 85, plus the last term, which is 505. And after evaluating that, you get exactly 4,425, but again, IB suggests that we round to 3 significant figures. You can leave the exact answer, but you can always round to 3 significant figures if you'd like to. So both of those 4430 trees or 4425 would be accepted, but I'll write it with three sig figs. And then lastly, it asks about the mean number of trees planted per month during the first 15 months. Well, to find mean, we just need to take the sum of all of them divided by the number of months, or the number of iterations. And so we have the sum of all of them is all the trees total is 4425 divided by 15, because it's 15 months. That will just average out the number of trees planted in total by those 15 months, and that gives us 295. And just a note here, even though you rounded, or you may have rounded, that 425 to 430 for part B, you always use the unrounded version for any follow-up work. Okay, number 3, we have an equation modeling problem, and you can see it's a quadratic. H of t equals negative 3.6 t squared plus 10.8 t plus 1.8 for t greater than or equal to 0. T is the time after a javelin has been thrown, and h is the height of the front tip of the javelin above the ground. Part A asks the height of the front tip of the javelin at the time it's thrown. One way to address this is to think about what would the time be at the time it's thrown? Well, that would be t equals 0. And so you can substitute 0 in for all those t's, and this term becomes 0, and this term becomes 0, and you're just left with 1.8. So if you don't immediately remember information about standard form of quadratics, that is my suggestion, is to just let t be 0 and find the value. And you can write that as h of 0 equals 1.8. But you can also just write down 1.8, because 1.8 is the constant term, and so for a quadratic, it's automatically the y-intercept, or the starting value. And it's always a good idea to include units. 1.8 seconds. Part B. Find the value of t when the front tip of the javelin reaches the maximum height. Now, there are several ways to do this. One of them is to take the derivative and set it equal to 0, because that derivative stands for the rate of change, and that rate of change would have flattened out when we get to the arc, the apex of the arc. But my suggestion is to just type this into your graphing calculator: y equals negative 3.6 t squared plus 10.8 t plus 1.8, and then use the calculate max option on your graphing calculator to find the maximum value. And we want the value of t, so that's going to give you, when you calculate the max of the curve, it will give you an x value and a y value, and t here is x. So we'll take the x value, which is 1.5 seconds. Now, in this case, you need to show what you did. So all you have to do here is sketch, like super duper quick sketch, the curve. And you want to put a point at the max, and I would write down that point, 1.5. Actually, don't have it in front of me what the y value is. 9.9 actually. So just sketching that sort of shape, letting them know that you found it by finding the maximum on the graph and labeling that maximum point is a sufficient amount of verification of your work. You can, by the way, do this by you can find the max or min of any quadratic by doing negative b over 2a. So as a side note, you could do, algebraically, you could do negative 10.8 over 2 times negative 3.6, just the b value and the a value. And when you calculate that, you'll also get 1.5. That's algebraically, and the left side here is graphically. And finally, for part C, find the value of t when the front tip of the javelin strikes the ground. Here we can imagine that the height of that front tip is now 0. So I would go back to your graphing calculator and find the zeros of this graph. And you can use the same graph you've already drawn here, label that point. You're going to see that that point occurs at 3.16, comma 0. And so your answer here is t equals 3.16 seconds. And I always like to box my answers because, as you can see, it gets pretty messy. Number 4. On number 4, you are asked to, first of all, write down the null hypothesis for this situation. Sergio, I'm not going to read through it all, but he wants to know whether an adult's favorite breakfast berry depends on their income. And depends is your keyword, and it's a chi-square test. So for chi-square tests of independence, the null hypothesis, or H naught, is, sorry, I shouldn't have written equals, is that the two variables are independent. And so we would say favorite breakfast berry is independent of income. Okay. Part B wants to find the chi-squared test statistic. You're going to have to create this table, create a table of expected frequencies in matrix form, and I have gone ahead. Let me choose a different color here. And you have to do that. You have to find the sum of each row and the sum of each column, and then the sum of each row, and then the sum total. And then you'll write a matrix where you take the row total times the column total divided by the total. So in this case, we had a row total of 90, a column total of 92, all over 341. And you can just type that straight into your calculator straight into the matrix, and it will do the calculation for you. Here, I'll just do one more example, 151 times 90 over 341. And when you have both of those matrices in there, the original and the new expected frequency matrix, then you can run your chi-squared test for independence, and you find that chi-squared is equal to 2.27. Now, the critical value, we're told, for part C is 7.78, so we can see that 2.27 is less than 7.78. You need to write that down. You may also notice that when you got that information that for P, you got a p-value of 0.687, which is higher than our 10% significance level. So critical value for chi-squared, if the chi-squared value is less than the critical value, that means we do not reject H naught. And the same thing for the P. If the P value is greater than that significance level, then we also do not reject H naught. So your conclusion is that there is insufficient evidence to reject. There is insignificant. Since we don't reject H naught, we assume that it's true and that there is independence. So we could say there's insufficient evidence to show that the berry flavor depends on income level. I'll try to abbreviate. Sufficient evidence that berry preference depends on, income. Okay, moving on to number 5. Here we have another model. This time it's an exponential model. So we just want to try to use our technology as much as possible and pay attention to the variables. In this case, we've got the capital T is the temperature and lowercase t is the time, and the time in minutes after the coffee started to cool. So we're asking for A, find the coffee's temperature 16 minutes after it starts to cool. So 16 minutes is going to be our time, little t. And you can write t of 16 equals, well, I'll write it. You can write that. Actually, it's probably a great idea to write it so you can show the moderators that you know what you're doing. Plus 23, and then just type that into your calculator and let your calculator evaluate it for you. And you get 54.2 degrees. And label that part A. Part B, write down the equation of the horizontal asymptote. One way to do that is to graph this and zoom out far enough that you can see where this flattens, but also, as you can imagine, if a coffee cup is cooling, it's going to be cooling and cooling and cooling and cooling until it happens to get to that constant term, that 23. Horizontal asymptote is just y equals 23. Write down the room temperature. Well, that's 23 degrees Celsius. Because at that point, the coffee cools and cools and cools until it gets closer to room temperature, and then it's going to stay at room temperature. And finally, part D asks for the T inverse, capital T inverse of 50 equals K, and wants you to give K. And what that means is that though normally we have our input value inside the parentheses, when we have an inverse function, that just tells us that the 50 is equal to t. So this equation becomes 50 equals 71 e to the negative 0.0514 t plus 23. And to solve this, I would just enter this into y1, the equation itself, and the 50 into y2, and on your graphing calculator, and find the intersection. And when you do that, you get that t, or k in this case, is equal to 18.8. Okay, number 6. We have some more tests, hypothesis tests. This time we're asked to write that alternative hypothesis, and Manny is trying to find out, or Annabelle uses the score to conduct a two-tailed hypothesis to compare the means of the two classes. It just says compare. It doesn't say to find that one is bigger than the other. So since we're just comparing, we want to know if they're equal or not. And so the alternative, well, the null hypothesis is mu1 equal to mu2. The alternative hypothesis is mu1 not equal to mu2. And that's all you needed to write for part A. For part B, find the p-value of this test. I'm not going to get into that, but other than to say you'll use your tests on your calculator statistics function, and it's a two-tailed t-test, or I mean, sorry, let's see, a two-sample t-test. And enter in that data. I guess you need to start by entering that data into the lists, and then use the data to compare, and it's going to give you that P for part B. When you run that test, that P is equal to 0.97652. It says correct to 5 decimal places, so notice it actually tells you that you need more than 3 significant figures here. And then state whether Annabelle's conclusion is correct. Because 0.97652 is greater than the significance level of 0.05, Anna's conclusion is correct. And you do need to include this part in your answer. You need to include the why, and that's the give the reason for your answer. Number 7, here we have a savings account. Here you're going to use your TVM solver, and I'm going to just let you know what to write. We know that, so by the way, on your calculator, you're going to the apps, to the finance app, the TVM solver. Leave the capital N blank for now. Well, we can start it. Capital N. No, we don't know what's going to go there yet. For I percent, we are told we have a 7.5% interest. The present value, think of this as money leaving Laviola's hands. And because she invests 800 euros, then 800 euros leave her hands. So think of it as that leaving her hands as a minus for the present value. And then for the payment, she also $500 a month leave her hands, so negative 500. For the future value, we hope she wants her account to get to 10,000. In other words, she wants to withdraw or get a positive 10,000 back. So that's a positive value because that money will come back to her, not leave her. And then we have a payments per year. She's paying 12 payments per year because she's paying monthly, and we're told that it's compounding monthly, so that's also 12. And we're told that her payments are made at the end, so highlight end. And now you just go back up to N and you do alpha solve. And when you do that, you wind up with N is equal to 17.3. The question asks the smallest possible value for K, and since K is a month, then she has to pay more than 17 months or K equal to 18 months. She has to pay in 18 months to have $10,000, enough to withdraw $10,000. So that is the answer to A. B, for this value of K, so now we're going to let N equal 18. I'm going to change colors here. we're going to let that n equal 18, and we want to know how much interest she's earned. So what we're going to do is go back and recalculate our future value with 18 months. And when you do that, you get, you'll do second solve or alpha solve here, and you get 10,389 plus some change. And that's how much money she has in her account, 10,389. But we also, in order to find out how much interest she's earned, we need to know how much she paid into the account, and we'll subtract that from the total. So she paid into the account a payment of 800 at the beginning, plus, sorry, I'll move that. Let's see, 800 plus 18 payments of $500, so 18 times 500. So when you calculate that, you get 9,800, and when you subtract that from 10,389, you get 589 euros is the amount of interest. Okay, moving on to number 8. Here we are doing some probability. So Roy's a member of Motorsports Club. He takes his laps are normally distributed. So it's the time he takes for his laps. So I'm gonna write T is normally distributed with a mean of 59 and a standard deviation of 3. We write that as 3 squared if we're writing it in this form. But we want the probability that he completes his laps in less than 55 seconds. So we're looking for the probability that T is less than 55. You can go to your stats and run, or your distribution, sorry. So second distribution, we want a normal cumulative distribution function because we want the probability that his lap is any amount of time less than 55. It doesn't have to be 55 exactly. So a normal CDF cumulative distribution with our lower value being -1, second E99, so basically as small as we can get it, and our upper being 55, with your mean or mu of 59, and sigma is 3. And when you run that, you get that, let me just make sure I did this right. Yeah, that probability is 0.0912. And that's the answer to part A. And part B, Roy will complete a 20-lap race. It's expected that 8.6 of the laps will take more than T seconds. So find the value of T. Here we're going to do the inverse of the normal. We know that, let's see, I'm having to refresh myself here, that 8.6, let's see, 8.6 of the laps will take more than T seconds. So he's doing, let's see, hold on. .6 seconds equals 20 laps times P, and that would give us, we can solve P equals 8.6 divided by 20, or P equals 0.43. So the probability of that, because that's the expected value, because 8.6 is the expected value. So the probability is 0.43. And then we want to know it's expected that 8.6 laps will take more than t seconds. So the probability that this is greater than t is 0.43. We could rewrite that as the probability that big T is less than little t is 0.57, or 1 minus 0.43. And then you can do the inverse function with the area of 0.57, the inverse normal, and the same mean 59 and the same standard deviation 3, and that will give you that probability is that gives you the t value of 59.5. Okay. On number 9, we have this probability of these two games that are played that are independent of each other. We want the probability that Taizo knocks over a total of 2 bottles. So he could do that within 2 games by knocking over the probability that he knocks over 0 the first turn and 2 the second. So we multiply those together. That's one way to get to. He could knock over 2 the first turn and 0 the second, or he could knock over 1 the first turn and 1 the second turn. And so we just need to multiply and add those values, and that will give us 0.5 times 0.1 plus 0.1 times 0.5 plus 0.4 times 0.4. And when you evaluate that, you get 0.26. And that's the answer to part A. Find the value for so in part B, we have some more information. Taizo will win K points if he knocks over 2 bottles, 4 points if he knocks over 1 bottle, and 8 points if he knocks no bottles. And we want to make sure the game is fair. And the way we know that the game is fair is when the expected point values or outcomes add up to 0. And so we can calculate the expected value by multiplying the probability by the outcome. And so in the first case, the probability of 2 bottles is 0.5, and the outcome, or the number of points, is k. So 0.5 times k. Plus the second, knocking over 1 bottle, has a 4.4 probability, and that will, let's see, he wins 4 points, so we multiply that by 4. And that he loses, I did that backwards. Let's go back to the first one. If he knocks over 2 bottles, that would be the probability of that is 0.1, and that's what gets multiplied by k. And then going back to this, if he knocks over 0 bottles, there's a 0.5 probability of doing so, and he loses 8 points, so that's times -8. And when you evaluate all of that, and all of that should equal 0. So you evaluate all that and solve for k, and that you get k equals 24. So it needs to be 24 points that you win for knocking over 2 bottles. Okay, here we have some log problems. And again, just try to read the problem and think about the input and output variable and use your graphing calculator or your technology as much as you can. Here we want to know the magnitude of accubens, and we do know the brightness. So what we're solving for here is M, and what we're given is B. And all you have to do for part A is write m equals 1 minus 2.5 log base 10 of b, or of 0.0525. Type that into your calculator, evaluate it, and you get that that's equal to 4.20, 4.20. And so that's m. That's your magnitude. Part B, we're given that series has a magnitude of 7, so 7 is m, and we want to find the brightness. So we want to find B, so I would write 7 equals 1 minus 2.5 log base 10 of B, and we want to solve for B. Now, solving for B here, you don't have to do algebraically, so my suggestion is to go to y equals and type in this as y1 and 7 as y2, and find the intersection. Use second calc to find the intersection. It may be tricky to find the intersection. You may have to zoom in a whole lot. You will. So just don't let that scare you if it doesn't look like it intersects at first. But once you do, you'll get that B is equal to 0.00398. And part C says how many times brighter is Acubin's compared to series, and number of times just means compare by multiplication or compared by division. So I would put the Acubin's brightness, which we know is 0.0525. It says Acubin's 2 series, so A over C, so 0.0525 to 0.00398, and divide that, and you get 13.2. And that's it. Okay, here is a geometric sequence, and you'll see why in a second. She's training for a marathon. Each day Christy increases the distance she runs. The point she reaches each day is represented by the x-coordinate, and the x-coordinate forms a geometric sequence. So that's how we know, and that should make you think about using the formula booklet if you need to. But first it just says, show that the common ratio R is negative 1.5. And we know that she ran, that day 1 is here, is 2, and day 2 is B, which we don't know what it is, and day 3 is 4.5, the X value. So I would do 4.5 over 2. We compare, 2, should equal the common ratio squared since 2 days have gone by. And so when you do 4.5, squared, 4.5 divided by 2, you get 2.25 equals R squared. And when you square root both sides to get R, you get R equals 1.5. Now it does say negative, and you'll notice that day 1, she ran east, which was a positive value. Day 2, she ran west, or negative. Day 3, she ran east again, so that's positive. So if the signs are changing every other iteration, then we know that we have a negative R value. So I would say I would show this part when you're showing your work, and then say because she runs in the opposite direction each day, the sign, the R is negative. Okay. So on the 6th day, Christy runs to point F. Find the location at point F. So we want to find the 6th term in a geometric sequence. So once again, let's go back to our formula booklet. You can see here we have geometric sequences, and That's in the second column or the second row right here, UN, or the U, whatever the nth term equals the first term times R to the n minus 1, or the common ratio to the n minus 1. In this case, we want U6 on B. And so it's U1 or 2 times the common ratio, negative 1.5, to the n minus 1 or 6 minus 1. And when you evaluate that, you get negative 15.2. And finally, part C wants the total distance that she ran during the first 7 days of training, which once we just want to add up all those different distances, or we want S7, the sum. And once again, use that formula booklet, and we get the sum in a geometric sequence by multiplying the first term times 1 minus r to the n over 1 minus r. So the first term, or 2, times 1 minus r to the n, which is negative 1.5, to the 7th, over 1 minus r, or 1 minus negative 1.5. And when you carefully type all that into your calculator, you get 64.3 kilometers. Okay. Here we get to a trig modeling problem. So notice there is lots of modeling on this SL paper 1. We are told that we have a sine function. So that's one thing you need to note. And we're told that when t equals 0, the height is 78. So you should remember that sine functions start at the origin and then go up and down and up and down. Unless there's a horizontal shift of c, in which case this whole curve moves up or down, depending on what c is. But we're told that when t equals 0, so that the starting point is at a height of 78. So actually what that means is that this was shifted up and its starting point is 78. And that's a poorly drawn line, but that happens at 78. And also that tells us that that's the value of c. So c equals 78, and we can tell that just by this information. The starting point is always of a sine is always the principal axis, and c is the principal axis, so c equals 78. When t equals 4, p reaches its maximum height. So imagine this is 78. That's what that means. It's reached its maximum height right here 4 seconds later, and that's at 143. So we want the value of a, which is, in this case, a is the amplitude, and that's just found by subtracting 78 from 143. So 143 minus 78 is 65, and a is 65. And my suggestion is to write 143 minus 78 equals 65, and circle that. You can always write centimeters, write the units. To find b we get from our period. Our period, you can see we've rotated a quarter of our circle after 4 seconds. So in another 4 seconds, we'll have rotated halfway. And then in 8 more seconds, we'll rotate the whole way. So that's a total of 16 seconds. So if the period is 16, we can find b by doing b equals 360 over the period, or 360 divided by 16, which is 22.5. And that's the value of b. And then it wants us to find the minimum height of point P. Well, if the amplitude is 65 and the midline or the principal axis is 78, then we just do 78 minus 65 to find our minimum value, and our minimum value is going to be 13. And now we are told that the cat is tired and takes twice as long for point P to complete one revolution. So now instead of 16 seconds, he takes 32 seconds. So 360 divided by 32 is 11.25, which is our new B value. Let me just make sure. Yeah. Okay. Number 13, we have some calculus. We are told that P is the cost per hour, and then it has a local. Here we can see this is the customers are charged to hire a boat per hour. Depending on the number of hours, the cost per hour can change. So, but right here, the cost per hour has a local min when the boat is hired for H hours. So find the value of H. We want to find the local min. Well, we should remember that the derivative, we can find any maximums or min, any extrema, by setting the derivative equal to 0. So for part A, that's what we do. 20 minus 980 over t squared equals 0. And then just solve for t. I would add 980 over t to both sides, giving us 20 equals 980 over t squared. Multiply both sides by t squared, and then divide both sides by 20, giving you 980 over 20 equals t squared. Or t squared equals 49. And square root both sides, t equals plus or minus 7, but here, since we're dealing with time, we only deal with the positive. So t equals 7, or h in this case equals 7, because h was the time. Okay, for part B, Sandra hires Giles' boat for 5 hours and was charged $328. So we have a t value here of 5 hours and a $328 per hour, which is our p. And we are show that the cost per hour for Yvonne is $312 after 7 hours. So for Yvonne, we have t and we're trying to show or find p. Okay, so in order to find values of p, we need to take the integral of dp dt, or the integral of, I'll just write it in up here. This is what we're doing. So the integral of 20 minus 980 over t squared, and dt. I like to rewrite this as the integral of 20 minus 980 t to the negative 2 dt. So then now when I integrate, I put that 20 becomes 20t. It gets a variable. Then minus 980 t squared, t to the negative 2, the t, that we increase that negative 2 to negative 1, and multiply negative 980 by negative 1, it becomes positive 980 t to the negative 1, and then add a constant at the end. Now, if I want, I could rewrite this back 20t plus 980 over t plus c. I need to find the value of c before, and that by the way gives me p. I need to find the value of c, and I can do that using Sandra's information. So p of 5 equals 20 times 5 plus 980 divided by 5 plus C, and all that should equal 328. And when I evaluate and solve that for C, I get that C is equal to 32. And so now P of 7 is 20 times, and this part you need to definitely write because it says show that, 20 times 7 plus 980 divided by 7 plus 32. And you'll want to type that into your calculator to confirm, and it does indeed equal 312. And I like to put a little check at the end to show that I did it. And look at that, we've made it through. All right, I encourage you to go back through this as many times as you can. Retake it over and over again, watching the video, not watching the video, looking at your answers, not looking at your answers. The more you do this, the more familiar you'll be with it, and the more you'll be able to reproduce it on your own and on different types of problems. Okay, good luck.